Hello all, welcome. In this lecture, we will discuss Huffman coding. So, in the introductory video of image compression, we have discussed various redundancies. In, in that, one was coding redundancy. To remove coding redundancy, what did we do? We used variable length coding. So, in variable length coding, what do? We assign more number of bits to more probable symbols and we assign more number of bits to less probable symbols, and we assign less number of bits to more probable symbols, and by doing so we achieve coding redundancy. So we are able to reduce the coding redundancy, and we are able to achieve image compression using that. So so to have variable length coding, we have one option that we can choose is Huffman coding. So Huffman coding also gives us uh, variable length coding. So this Huffman coding is popular for removing coding redundancy, as we have discussed, because it will give us variable length coding. Now, this Huffman coding is performed in two steps. In first step, what do? We reduce the source. So first step is source reduction. So this, this is the table in which symbols are given and the probability of occurrence of each symbol is given. So in first step, what do? We arrange these symbols in the ascending order of their probability of occurrence. So you see here we have arranged them in the descending order of their probability of occurrence. So the maximum probability we have kept up at the top, then zero point 0.3, 0.1, 0.1, 0.06, 0.04. So in the descending order we have arranged them, and we have kept the symbols also in that order. Right. After that, in source reduction, in first uh, step, what do? We add the probabilities of least two symbols. Probabilities of two least probable symbols. We add them and write the remaining probabilities as it is, and at last we will write the sum of the least two probabilities. This we will write. Then we will add here, this is the first step. After that we will add again the least two. We will add again the least two. So zero point 0.1 and zero point 2, point 0.1 will be zero point 0.2, and then the resultant we will arrange them again in the descending order. So zero point 0.4, this is as it is, zero point 0.3 as it is, then zero point 0.1 and zero point 0.1, zero point 0.2 that will come here, and this zero point 0.1 goes at the bottom, since this is the least among these four probabilities. Then now we will add the least two, so that is zero point 0.2 and zero point 0.1. So zero point 0.4 goes as it is, zero point 0.3 goes as it is, and the sum of these two is zero point 0.3 that goes at the last position. Then again we will add two least probabilities. So the sum of two least probabilities is zero point 0.6, that is more than zero point 0.4, so that will go at the first position, and zero point 0.4 will go at the second position. So we will keep on doing this until we reach to the two probabilities or two sources, we can say. So this is called what? Source reduction. So in source reduction, what do? We add two least probabilities, and then we make only one out of them, and again we arrange them in the descending order. Again, add least two, arrange in the descending order, add least two, and arrange in the descending order, and we have to stop when we get only two probabilities or two sources. Now this is the first step. In second step, what do? In second step, we assign the code to individual probability. So we start from the last reduction. That means this fourth reduction we start from here. We assign 0 and 1 to each probability. So zero point 0.6 and zero point 0.4 was the last two probabilities which we had got. So we will assign 0 to one and 1 to another. So we assign 0 to this and 1 to this. Now we know that this 6 we had got by adding these point 0.3 and point 0.3. So what will happen? This 0 will go as it is here, and 1 0 will be added here, and one will be added in the right hand side of this 0 to distinguish between these two probabilities, that these two are different. So this 0 will come as it is here on the right hand side. For one symbol 0 will be added, and for another symbol 1 will be added, and this 1 will go as it is in the previous column. Hope this is clear. Now we know that this point 3 we had got by adding point 2 and point 1. Point 2 and point 1. So this 0 1, 0 1 will go as it is, 0 1 will go as it is, and 0 1 will go as it is for both these symbols, and 1 0 will be added for one symbol, and 1 1 will be added for another symbol. So for one symbol 0 will be added, and for another symbol 1 will be added. So this is how we propagate back. And since we did not change to this point 3, so this point 3 code symbol comes as it is, and this point 4 also we did not change, so this one also comes as it is here. Then after again this point 2, we know that this point 2 we had achieved by adding point 1 and this point 1. So this point 2 0 1 0 comes as it is for these two symbols, that is 0 1 0 0 1 0, and 1 0 is added for this symbol, and 1 1 is added for this symbol. So 0 and 1, and for remaining it comes as it is, point 4 as it is, this point 3 as it is, and this point 1 as it is, that is 0 1 1, like this. Now here also we have got this point 1 by adding these two probabilities, 0.06 and 0.04. So this 0101 comes as it is, 0101 comes as it is, and 1 0 and 1 are added to distinguish between these two symbols. To distinguish between these two symbols. So 1 0 is added here, and 1 1 is added here. Remaining this point 1 comes as it is, this point 1 comes as it is, point 3 comes as it is, and point 4 comes as it is. When we reach back to the original probabilities, when we come reach back to this original probabilities, we get this code, and this is our variable length code, and this we have done using Huffman coding. So this is how we achieve Huffman coding. So it is done in two steps. One is source reduction. In source reduction, what do? We add the two least probabilities, and we go to the next column. Such we this operation we will be doing until we reach last two probabilities, and then we assign codes to each probabilities. So last two we will assign 0 1, and then that uh, addition will be propagated back, and that bit comes as it is, and 0 and 1 will be given to the probabilities to distinguish between the previous probabilities. So 0 is given here and 1 here. So like this we will propagate back, and we will reach to the original probabilities, and this will be our code. This is variable length code. So here we can see the A2 symbol A2 has the most probability, that is 0.4, and it has the least length of the code, that is 1. And A6 has the next probability, that is 0.3. It has two length code, and 3 length code, then 4 length, and then 5 length, and this is also 5 length. So the least probable symbols are coded with more number of bits, and most probable symbols are coded with less number of bits. Now, if we want to find out the average length per symbol, average bit length per symbol, then how do we find? We have the formula, that is summation I is equal to 0 to n, 0 to l minus 1 prk and multiplied by LRK. PRK multiplied by LRK. That means simply we multiplied the code length by the probability of occurrence of that symbol. So this code, this symbol has code length 1, it will be multiplied by its probability, that is 0.4. This symbol has the code length 2, it is multiplied by its probability 0.2, and it has 3 multiplied by zero point 0.1, and so on. We will multiply all the symbols code length by its probability, and the product will be added. The product will be added and it will give us the average number of bits per symbol. So it comes out to be 2.2 bits per symbol. And if we find the entropy of this source, if we find the entropy of this source, that comes out to be 2.14 bits per symbol. So the efficiency of the code is given by entropy divided by average uh, symbol symbol length. So entropy is 2.2 bits per symbol, and the length is average symbol length is 2.14 bits per symbol. So when we divide this, we get the efficiency is equal to 0.973. So this is the efficiency of this code which we have uh, achieved by using the Huffman coding. Now, if I say that this is the Huffman code, this is written for these symbols only. So, if we want to find out if we want to decode this code, then you see the first symbol which we achieve here is 01010. So 01010, because 01 is there is no symbol for 01, for 0 also there is no symbol for 01, 010 also there is no symbol, 0101, these two are matching with 0101, and then finally it is 0. So first symbol we have is A3. So we have got A3 symbol here. After that we have 0 1. So after that we have 0 1. So there is no symbol for 0 1. Then we have 0 1 1. So 0 1 1 corresponding to 0 1 1 we have A1. So we have got A1 here. Then we have got 1. So corresponding to 1 we have A2. So we have got A2. Then again we have 1. So corresponding to 1 we have got A2. And then we have got 0. But corresponding to 0 there is no symbol here. So corresponding to 0 0 we have the symbol A6. So last is A6. So this is how we can decode the symbols from the Huffman coding. Now, but the limitation of this Huffman coding is if we have J source symbols. If we have J source symbols, then we have to go for J minus 2 source reductions. Then we have to go for J minus 2 source reductions. So in this case, if we see, then there are total 6 symbols A1 to A6, and we had to go for 4 times the source reductions. So if we look in with respect to the image, then we will have total 256 symbols, 2, 256 different gray levels. So for that source, we need to go 254 times for the source reduction. So that is a type of computationally expensive process. So that is one limitation of Huffman coding. So that's it for this lecture. We will meet in the next lecture.